our group has decided to do our presentation on a Wireshark analyzation of Netflix and Hulu. We thought this would be interesting to do a comparison of the two largest streaming services on the internet today. We are Group 1, and our group consists of Evan Nunley, Betty McCorrigan, Peter Martinez, and Douglas Schultz.
So why does it matter? Why is streaming service important? Why is streaming traffic worth analysis? I think we all recognize that over the past decade or so, video streaming has become kind of the dominant force of data transmission across the internet. The majority of internet traffic nowadays is video. And as connections become more robust, internet speeds increase, cellular networks evolve, and content becomes more readily available, our group decided that was enough of a factor to take this project on. So the objective here is to review the patterns and behaviors of traffic itself. And that way we'll understand how streaming videos are delivered to the end user. And we're also going to compare and contrast those two streaming services, Hulu and Netflix, for any kind of discernible similarities or differences in how they operate and how they perform.
Hey everyone. As mentioned on a previous slide, our group chose to review two streaming services, Netflix and Hulu. I got the lucky break of dealing with Netflix for this Wireshark capture. I've definitely spent way too many hours on this site myself. So to kick things off, we'll quickly go into Wireshark, and we will start with a capture. We'll also pull up the episodes and start streaming it and see how this interacts with the different packets. So we'll let it stream for a couple of seconds, and then we'll go back into Wireshark and see how everything looks. So that should be a decent amount of time. We'll go back into Wireshark and we will pause it. So what you'll actually notice in some of the slides after this is, unlike a true streaming service, what Hulu as well as Netflix do is they first try to buffer up to about 5 minutes worth of data right up front. So what you're going to really see is if we actually open up Wireshark and do an IO graph and we zoom out, if we were actually to have this run much longer, we'd actually see some recurring spikes. But right off the beginning, we can actually see a very large increase in bytes of data. So here's another quick graph that would show it over time. So as you can see, it kicks this off, has a very high amount of bytes, and then stops buffering for a period of time until that 5 minutes of data starts to dissipate. At that point, it will buffer again, and the cycle will continue. What you also notice, and what I wouldn't have guessed, is actually this is doing it via TCP instead of UDP. I would have thought because this is a streaming service, it would have cared more about getting the data over instead of making sure it all actually arrived there properly. So as you can see, you'll be able to go through a lot of the TCP packets, there's some TLS, and so forth. So now that we've taken a quick glance at the Wireshark information, just wanted to bring your attention to a couple of other important graphs. So in the upper right, we've actually already shown this one. This is the buffering and the increase in data over time. As mentioned, it quickly buffers everything in the beginning to about 5 minutes. So if you need to do any playback, anything along those lines, you'll be all set. The other interesting thing that happens specifically with Netflix is it's actually only leveraging 3 specific TCP connections. So here is a more in-depth graph that we found that actually shows what this would look like. So as mentioned, also in the beginning, you have that very large spike as it's filling the buffer. And then afterwards, a lull until that information starts to dissipate and it needs to start to buffer again and again. And the trend will continue. When we had first started this project, I honestly would have thought that the buffering would look more like a straight line and it would stream data consistently over time. A very interesting way that they came up with this problem solve.
I'm Schultz. I am on team 1 of the Champlain project group. We are working on our Hulu and Netflix streaming project.
and we're going to show you kind of what we've done so far. So to start with, just take my word for it. I've already done about 38 seconds of streaming of this Watchmen episode via Hulu. And so for the sake of time, I went ahead and did that before we started the video. But we went ahead and ran that through Wireshark. So here is just kind of an example of the Wireshark packet capture. You'll see there's a lot of data. The majority of it is TCP traffic with kind of these various TLS interludes as it flows through. So what does this mean? What are we looking at? How does this tell us anything about Hulu? So the way that video streaming works, and this is not just Hulu, but really anything, is streaming, quote unquote, is kind of a misnomer, right? Instead of one continuous flow of traffic, it's actually centered around an initial download to kind of fill up the buffering window. And then as that video content is consumed, there are smaller subsequent downloads to refill that buffering window. So here's actually the graphical illustration of the packet capture, and it shows just that. The initial spike of data coming down and sort of the various refills as we go and consume that video content. So if we go through this here and kind of click on the corresponding packet lines, you'll see this initial download to start is a massive stream of TCP traffic, right? We can keep scrolling, it's never really going to end. If we go to the kind of the smaller reloads, let's just go to the first one as an example, you'll see it's a much smaller stream, right? We start the TCP traffic kind of here, and after kind of a quick little scroll, it's over, and we start seeing different traffic. So, a good illustration there. And one of the other things we wanted to mention as we're looking at this, right? We've actually learned through our research that Hulu and a bunch of other providers of streaming content house their stuff, their data in Amazon Web Services. And so when we pulled some of the IP addresses that we were consistently seeing in the data packets, we saw two things. One, we actually found the Amazon data service or Amazon Web Service data center in Portland, Oregon, associated with this IP address. So this IP actually showed up in our packet capture over and over, and we were able to locate kind of where the data was originating. One thing we also saw that was kind of surprising was this IP address belongs to Level 3 Communications, which is an ISP, and this was actually one of their one of their central offices in Dallas, Texas. Interestingly enough, another thing we learned, and that's illustrated here, is that video content providers will also kind of distribute their data and replicate it at the central office of ISPs so they can more easily distribute it more efficiently, right? So it's not all just coming from one central source. It can actually be kind of locally distributed to wherever the closest source is. So that was also something we found that was interesting. So overall, again, not one continuous stream. It's a big initial download followed by some refill downloads as that data is exhausted. And that's what we saw in our packet capture. Thank you, and look forward to your feedback.
So in summary, comparing the two video streaming services, Hulu and Netflix, operate in a very similar fashion. However, they're truly not streaming services. They buffer the data throughout the viewer's streaming experience. While streaming in the end may equal the same number of bytes as if it were truly streaming the content, it does this in a more compact way, primarily front-loaded. So in conclusion, when making a decision between these streaming models, really you should be looking for what type of content is within them and not actually the streaming ability.